All right, guys, I apologize. I've been away for a while. A lot has happened. I am starting a lab. I couldn't be more excited to be starting a research lab. But today, I have a story for you out of the medical literature that is mind-bending. It is about the eastern chipmunk. The article I want to talk about is called Consumption of Red Maple in Anticipation of Beach Mast Seeding Drives Reproduction in Eastern Chipmunks. That, as you can see, is your regular chipmunk, and they're cute with their, their little pouches full of seeds, right? Don't you just want to tickle their little bellies? So this is the abstract of the paper. In southern Quebec, eastern chipmunks exclusively reproduce during the summer before and the spring after a mast seeding event of American beach. They seem to anticipate beach mast by reproducing during early summer. To be clear, mast means nuts and seeds in forests that fall to the ground to feed animals. And in number 2 here, it says the cues allowing the chipmunks to anticipate beach mast remain unknown. So we have literally no idea how the chipmunks know if there's going to be a beach mast seeding event. And it says the results revealed a systematic shift in chipmunk diet towards red maple seeds in springs preceding a beach mast, with red maple seeds composing more than 77% of the chipmunk diet. However, red maple consumption, and this part is important, red maple consumption was unrelated to red maple production, but was related to beach seed production in the upcoming fall. And then lastly, our results confirm that chipmunks anticipate beach mast seeding and highlight a key role of red maple consumption in that anticipation. Okay, so here's what that looks like on the graph. So what you see is the chipmunks. This is the black bars are, that's how many chipmunks are born. And this is beach, the dotted line here is kind of beach mast production. And so you can see in 2006 in the fall, there's a great beach mast production. So of course the chipmunks have already reproduced, and they'll reproduce again at the end of this spike. And presumably that is because the beach mast is a great source of food for the baby chipmunks. And so then in 2007, there's no beach mast crop and no chipmunks are born. 2008 is a good mast year and there's chipmunks. 2009 is a decent mast year and there's some chipmunks. There's a little break here in the middle. I don't know. Researchers went to Ibiza or something. And then here in 2012, in the fall, no mast, no chipmunks. But somehow in 2013, the chipmunks know that there's going to be a mast crop that year. And so they have their chipmunks. Okay. And so this is where the rubber hits the road. And so if you guys watch these videos, you probably know that I've been talking recently about the idea of protein restriction, especially restricting branched chain amino acids in both mice and in some small scale clinical trials in humans can restore insulin sensitivity and can go a great way towards kind of fixing metabolic syndrome. And one of the things that we see is that, at least in mice, when they bring their level of protein down to about 5%, you see this huge increase in the metabolic rate of the mice. And so, but then the question is, okay, well, how much protein do we really need, right? Is it safe to limit protein calories to, or protein to 5% of calories or 6% of calories? I point out sometimes that if you look at countries in West Africa where they have the lowest rates of diabetes in the world, those diets rely on a lot of tubers, things like cassava and plantain, which are both very low in protein. And so when you look at a national level, people are consuming less than 9% of their calories as protein in West Africa. But what's super fascinating about this, and you'll see on these last couple of slides, the red line here that spikes up from the bottom, that's production of red maple seedlings. And these little diamond shaped things, that is when the squirrels are eating a lot of red maple seedlings. Sometimes these line up. Obviously you can see here it's 2007. There's lots of red maple seeds and they're eating red maple seeds. But if we look here in 2017, the red maple seed crop that year is actually quite small, yet the chipmunks are eating a huge amount of red maple seeds. And that's because there is about to be a mast seeding event in the beach seeds, which is about to happen later that fall. And so in the year when there's going to be a beach mast seeding event, the chipmunks, and to be clear, chipmunks are hibernating squirrels, hibernating ground squirrels, and they store huge food caches underground in their burrows, right? And so they've got like a food pantry. And so this 2017, the most recent really good crop of red maple was back in 2015, and then before that in 2013. And so all of these red maple seeds that they're eating here in 2017 are probably, they're just pulling them out of their burrows from previous seasons because they know there's going to be this seeding crop, and there's going to be beech seeds for the baby chipmunks to eat. What are they in the years when they're not eating red maple seeds and there's no beech crop? And the answer is this. And so the main food that they consume are trout lilies. Trout lilies are little, they grow in my hedgerow over here. They grow under maple trees. They grow in dense forests, and they're these little lilies, and they have a tuber. They grow a tuber, and the tuber is very small. It would be too small for you or I to bother with, but for a chipmunk, it's a perfect size. And you can see in these off years, 2014, and in a post-mast year, the bulk of the chipmunk diet are these trout lily tubers. Scientists didn't collect the trout lily tubers and send them in, but this is the closest related thing that they could find in the literature that was similar to a trout lily. And so when you look at that, it's very high in carbohydrates. It has no fat, and protein is very low. It's only about 5%, right? Here's the maple seed. So the maple seed is also relatively low in fat. It has some carbohydrates, but it's 20% protein. So these maple seeds are actually very high. It's the highest protein food that the squirrels have available to them. And so what are the chipmunks doing? Somehow they know when the beech mast is going to happen. We have no idea how. It's magic. In those years, the female chipmunks switched their diet from a base of these trout lilies, which are only 5 or 6% protein. And in normal years, if they're not having babies, if they're not reproducing, they just eat the trout lily tubers at 6% protein or whatever it is, and they're perfectly happy. And because they're adults and they're not growing and they're not reproducing and they're not lactating, right? They're just hanging out being squirrels. And animals don't really need more than about 6% protein probably. But if there's a beech mast seeding coming, they switch to the high protein food, which they have stored underground in their burrow for just such an occasion, right? And so they're like, now we need to grow. We need to reproduce. We need to raise babies. We need to lactate. So now we need to go into growth mode. And so what we're going to do is we're going to switch from these 6% trout lily tubers, and we're going to eat these 20% protein maple seeds. And that puts them into this anabolic mode. And I think here's the problem, right? Here's where the rubber hits the road. If you're an adult human, you don't really need to grow. You don't really want to grow, right? Growing is definitely what you don't want to do. This paper suggests to me that on some inescapable level, high protein is associated with growth. And we can say why that happens. Leucine activates mTOR, which is an anabolic. It's part of signaling networks within cells. As an adult human, you don't need to grow either. I mean, unless you're a woman of reproductive age and you're thinking about having kids, of course. The rest of us are not growing. We may not need 20% protein in our diet. We might be able to get away just fine with the 5 or 6% protein. What I come away from this, what I think is really a mind-bending tale about chipmunks. I mean, think about all these things. One, somehow they know that the beech mast, they know when it's going to happen. So that's a little bit mind-bending. Then they have these two staple foods that they store underground in their burrows that they switch back and forth between on years when they will or won't have to reproduce. And the thing is, the adults, I don't know if you saw, is the little blue in that thing. They don't even really eat the beech seeds. The beech seeds, I guess, are for the baby chipmunks. I don't know. So the adults are just switching back and forth. In non-reproductive years, they go to the 6% protein food. If they have to grow, they go to the 20% protein food. So I think, maybe that's what protein is for in a true biological context. The protein is for anabolic things. Anyway, that's it for this week. I'm going to keep having these videos They might be, I've got some new responsibilities, so they might be a little shorter like this one, but Fire in a Bottle is not going anywhere even after we start this new lab. I will see you guys next week. I hope your mind is blown by these chipmunks.